Okay, so we'll be solving the second problem here. Here we have a cart that has an initial momentum and it's slowly filling with water. So of course this cart will slow down over time as a result of its increased mass. And the key here is how long, or the question here is how long until the wagon is moving at less than 1% its original speed. Okay, so the first thing we're going to do is just get a sense of what is the initial momentum of this system. The initial momentum is going to be 3... Oh, looks like my friend played a chess move. Sorry about that. 3 times 10, that's the initial momentum of the system. And now that has to equal the final momentum of the system. Now, this thing has been gaining water, so we're going to call it mass final times final velocity. This right here, this final mass, is the whole point of the question. We don't know how much water has to be in the wagon for this thing to happen, but we do know that the final velocity has to be 1% of 10. So I'm just going to rewrite this now as 30 equals this unknown final mass. What's 1% of 10? 0.1. Okay. So the final mass has to be 300 kilograms. Right? So when the mass is 300 kilograms, then we're at 1%, or right at 1% of its original speed. I know it says less than 1%, but without getting too in-depth in the math, it has to do with something called limits. We could say 300.0000001 kilograms, but you can imagine like an infinite number of zeros and then like a 1. It's easier just to call it 300, because that sets it at 1%. Okay. So we need a final mass of 300 kilograms, which means that the mass of the rain has to be the 300 minus the weight of the wagon, or the mass of the wagon, so 297. So we have to have 297 kilograms worth of rain. Now the mass of each raindrop is 1 gram. So how many raindrops is it going to take to get 297 kilograms? Well, it's going to take a lot. So how many raindrops? It's going to be 297 divided by 0.001, right? How many times does 0.001 go into 297? A whole heck of a lot. 297,000 drops. That's a lot. Okay, so now what we're going to do is we take a look at the rate. It's falling at 30 drops per second. So how many seconds is it going to take to get this 297 drops? So what we want to do is we're going to say we want 297,000 drops, and it's 30 drops per second. So what is 297,000 divided by 30? 9,900. That's not particularly useful. How many seconds are in an hour? It's 60 times 60, so 3,600. So let's just do it that way. So this is going to be 2.75 hours, which is 2 hours, 45 minutes. And that's how we would do this one. Okay, here's a solution for the first, the problem for Monday. This is a grenade problem. So here... If you think about this thing, the initial object has momentum here, and that has momentum in the x direction, so we'll call it pix, and it has initial momentum in the y direction, so piy. Now, all these other pieces also have momentum in the x and the y direction, so let me just jot those in real quickly. I'm going to call this object 1, by the way, so we'll call this p1x, we'll call this one p1y, this one right here, we'll call this object 2, so we'll call this maybe p2y and p2x, and this unknown object I'm just going to call 3. That's going to have p3x and p3y. Okay. So the one thing we know is that the initial momentum in the x direction, p1x, or sorry, p initial x, has to equal all the x momentum at the end. So p1x plus p2x plus p3x. Right? There's a conservation. So now we just got to figure out what these values are. So the initial momentum in the x direction is going to be m, so it's going to be 15, this is the mass, and it's going to be 30 times cosine of 25 degrees. That's the x, that's what I just did for right there. P1x, now that's a negative value. If you look right here, this goes to the left, and that's going to be a negative value, so that's going to be minus 3 times 45 cosine 40, is it 4? Now P2x is a positive, so plus 565. Now we got to be careful here. This x, notice how the angle here is given right there. It's the angle with the vertical. The opposite side right here is the x component is the opposite side to this angle. So we can't use a cosine function to get this side. We have to use a sine function. Again, because we're given the opposite angle, this side right here is a sine function. Right, so katoa. And now P3x, the mass of 3 it's really simple. You start with 15, and then here's 3 and 5, that's 8. That means there's 7 left over. So this has to be 7 times, now we don't even know what VF and cosine of theta is. We don't know either of those things, right? In fact, you know what I'm going to do? Just to make this easy for right now, we're just going to leave this as P3x. Might be easier that way. Okay. So now, if we calculate this out, remember, all these things are numbers, which leaves P3x equal to, and I'm going to take a look at my answer key up here, P3x. That looks like 302.35. I just don't want to take the time to recalculate that while I'm doing a video. But anyways, you can see that it is right here. That is, that's where I'm getting this 302. All right, now we're going to do the same treatment for the y direction. So P initial y has to equal P1y plus P2y plus P3y. So let's do the exact same treatment. It's going to be 15, 30 sine 25, and that is for the initial momentum, the initial y momentum of this object. All right, P1y is a positive value. So it's not going to be a negative on this one. It's going to be 345 sine 40. Now P2y is a negative. Notice it goes downward. So this is going to be a minus 5. And again, we got to be careful. The y component is the adjacent side to this angle, so that's going to be a cosine function. So it's going to be 65 cosine 40 plus P3y. And P3y is a positive, so let's just keep it as a plus P3y. So P3y is equal to, now again, these are all just numbers. I don't want to take the time to calculate it while I'm doing a video. So I'm taking a look at my answer key from up here. It looks like it's 352.37. 352.37. Okay. Oh, by the way, this takes care of our mass. The mass must have been 7 kilograms. So this final object has x velocity of a positive 302.35, and it has a y value, a y momentum of a positive 352.37, which means that the actual momentum, the actual final momentum of this third object is going to be the resultant, or if you think of it, Pythagorean theorem, it's just going to be the resultant of those two angles. And without taking the time to recalculate, it is going to be, where do we have that? Well, I don't think he has that one separated, so let's just go ahead and do this 352.37 squared plus 302.35 squared equals, take the square root. So the total final momentum is 464.31. And remember that's equal to m3v, the final velocity of this third object, right? Because momentum is mv. So the actual velocity is just simply going to be this divided by 7. So the final velocity for this third object is going to be 66.33 meters per second. And the angle here you can just get from the inverse tangent of 352.37 divided by 302.35. And without taking the time to calculate that, 49.37. So there we go, and that's how you would solve this one. Final velocity, 66.33 meters per second, theta 49.37 degrees. Okay.